My name is Mateusz Strąg. I'm a developer, TypeScript developer at VirtusLab. I will be talking about the code analysis and visual code representation. The presentation should take about 30 minutes. And at the end, there will be time for some questions. Okay, so first part of my presentation will be short brief about static and dynamic code analysis, differences and available tools regarding front-end development, mainly TypeScript, and of course, it will be applicable also for the JavaScript. In most cases, static analyzer tools will detect and correct anomalous code in your project before you compile it. This type of analysis addresses weakness in source code. Of course, this may also be achieved through manual code reviews, but using automated tools is much more effective. First of all, static analyses are done in early phase of development before testing. Will give you feedback immediately. It will be easier and faster to fix those problems. You don't need to wait for the test results. Setting up analyzer tools could prevent you to push code with some common anti-patterns, which could evaluate to bugs or errors on productions. Theoretically, you could spend less time on testing your code. One of most important thing, in my opinion, is that when you combine it with prettier, you could and your team codes, your code base will be more consistent. Next thing is probably nobody thought about it, but you can even learn by spending hours on investigating how this warning or error could be fixed and why I should fix it. This is a great example of ESLint and many of the rules, which sometimes we will thinking why this rule is in the ESLint config. And when we search it, the documentation, they've got very well documentation, and we can read and know why this rule is important. There are multiple tools for analyzing code, and by using them, you can detect many problems. What static code analysis can do? It can guards. Static analysis tools will guard your code base, guards your stylistic preferences, guards best coding practices for TypeScript or even for specific framework used in your project, will guard security, won't allow you to use outdated packages or some insecure methods. Also, something important in huge projects, copy-paste detection. We have static analyzer, which could prevent us for doing this. Static analyzer will give you metric about your bundle size. And don't forget that you could, or even you should, develop app friendly for people with disabilities. Simple rule sets could help us in this area. Static code analysis is used for specific purposes in a specific phase of development, but there are some limitations of static analysis. For example, no understanding of developer intent could slow down development, could be irritating, could be hard to set up in old legacy projects. But remember, it's up to you and your team to choose the best tools and rules. They should guard quality of your code, but developer experience shouldn't hurt. It's always better to disable some rules, but still apply it in a project. About available tools, we have few. Sorry. Okay. The first one is slint. It is very common, and I think it's the first choice we should take for our project. I highly recommend the Airbnb configuration, which of course includes some of the below, like for the importing, for the accessibility, for the specific framework like React and React hooks. And to support TypeScript, we don't need, and now I recommend to use slint, not tslint, but slint, with just the parser, TypeScript slint parser. Yes, so this configuration is I highly recommend. We can see on the graph the current trends for the slint configurations. Another tool is depcheck. This is a very interesting tool which will search your dependency in your projects. It will list, it will inform you that some of the dependency which you listed in the package.json is not used. And the other way is that when you use dependency which you didn't list in package.json, it will also warn you about this. However, depcheck, even if they in their GitHub documentation they say that depcheck just walks through all files and tries to find the dependencies according to some predefined rules. However, the predefined rules may not be enough or maybe even wrong. They say that, and that's true. It is a really good tool, and I recommend it for the new projects. When you set up a new project in TypeScript, go ahead and include depcheck in the continuous integration. But however, there are problems with the current existing projects because it will warn you, as they said, with some predefined rules. So they could warn you and throw an error that there are problems, or for example, that you can remove some dependencies. And when you go and do exactly what they say, in my case, on one of my projects, it fails. It didn't build after changes which they recommended. So for new project, yes. For the current projects, it's be aware of this situation when not always it's correct results give us. Another tool is the Webpack Bundle Analyzer. Mainly it's produce for us the metric with the bundle size, and not only bundle size but also divided into the smaller chunks. It shows which modules, how many, how big is it in the final bundle. For example, here we can see, here we can see that this is one of my projects. It's math.js, and tree shaking doesn't work well here. So it includes in the bundle all of the math.js library, which, to be honest, I used only the parse.js. Maybe parse.js has some other dependency inside it. However, I just use only this fragment. But in the bundle output file, it's added all of the math.js. So this is quite nice. I recommend, for example, to some regular, maybe some each release, you can check about this bundle size. Okay, next one is TowelE. It's a copy-paste detection. You can set up it with some thresholds, and it will detect the fragment of code which are exactly the same. Here we can see, for example, that there is one fragment which is presented in two places, in one file and in another file. So this one could be extracted. It still doesn't fail and doesn't stop our build process because we set up threshold with 95%, and there is a 99% of not duplicated code. Okay, another tool is the Lighthouse. It's in the Chrome DevTool. When you go to the Audit tab, you can make an audit for the whole website. It will show you a few metrics like performance, accessibility, and so on. And inside Lighthouse has few dependency which we can use as a standalone just for our use. And for example, this is the is website vulnerable. We just specify the URL and it will grab the website, look for the dependencies, and produce the results with some vulnerabilities found. Also, to search for the possible vulnerabilities, there is npm audit. We can search for the packages in our project. However, it's just searching for the module in our node modules, and it will inform us that this is high or moderate risk. Problem of this is that it will give us many prompts with many errors or warnings, which are not accurate for our project. For example, we don't have to use this specific method, but they will wrote that all packages has high risk. But in our case, it doesn't. npm audit fix, it will automatically fix paths by upgrading vulnerabilities. And we need also to be aware that our build can fail after such fixing. This is example. It showed that there is a moderate or high risk and some description, of course, packages and description of the yes, here, description of the vulnerability, code injections, denial of service, XSS. There are many of the possible descriptions. Another tool, very nice tool for the scanning the security for the Node.js applications. In that case, it is an Express app. This is the Node.js scan. It has built-in the dashboard, so it is also nice for us to read it. And in that case, there is the XSS in this, and it's showing also the snippet of code. So it's also worth to consider for the Node.js app. Question: when to use static analysis tool? I think answer is simple, always. And I think nobody doubt in it. In all projects, there should be some static analyzer. Even in legacy huge project, which is not easy to set up, but for sure it's worth. Even if some rules will be disabled, it is still worth to set up this analysis for the project. In opposite of static, we could analyze our code dynamically, which means analyzing during program execution. Dynamic code analysis can produce metrics with consumed resources, like memory leaks, performance analysis, security, race conditions, uninitialized accesses, concurrency issues, undefined behavior situations. So in general, dynamic code analysis could expose vulnerabilities and bugs that can only be revealed at runtime, like yes, like this below. Dynamic testing is most important in the areas where program reliability, response time, and consumed resources are crucial. Mainly, it's the dynamic code analysis is useful for the C language families. What's the limitation, disadvantages, and pitfalls of the dynamic analysis is that they could slow down application performance when we wanted to measure it in the production on our production. Then dynamic analysis focus only on actually executed code, in opposite of the static, which go through all of our code. In some cases, dynamic analysis are covered by tests, manual or automated. We don't have many to choose for dynamic analysis. Personally, I've used Chrome Profiler when I had problem with memory, once it was with memory, and once it was a problem with responsiveness, there was too long call stack. So there was two situations where I use it, and I need to investigate where is this problem. Okay, we said about static and available dynamic analyzer tools. What else could be analyzed? Monorepo. Some ESLint rules like unused variables doesn't apply when you have monorepo or few repositories. Dependency. There is no good tool for analyzing dependencies, packages dependencies, and code dependencies. Git history. Currently, history is per line, but would it be nice if there will be a chance to track history per token? And also meta information. We could grab much more information from our code. Mostly meta information will be valuable not for us, but for management. However, all of these things are available to grab only from code. For example, from Git, it's long-lived feature branches, most problematic code areas. We can measure the technical risk when a key developer leaves the project, detect subsystems with low team autonomy that became productivity bottleneck, risk due to modifying multiple layers like view controller services at once. And as well, we can estimate the impact of for our system when we are implementing some feature, for example, in core areas like authentication. Okay. Git. About the Git, there is also developed internally by VirtusLab extension like ContextBuddy. What is interesting in ContextBuddy is that it will bring you Git annotate to the next level. It's not showing per line, it's showing per token. I will show you. Okay, and this is some example of the code. And oh, sorry, what's going on? Okay, and normally when you go for example, for this line, hope you see my mouse indicator. When you go for some of line, you can see that author of this line is, for example, me, Mateusz. But unfortunately, I added only a comma or some separator, or so if somebody, for example, new in this project, look at this code and try to find person who know this fragment and could help, he will go to me because I'm last author of this line, but I just added the comma. So maybe it is worth to look at the specific token, specific alphanumerical character. And we can do it with ContextBuddy. We can just download, install extension from the marketplace and switch it on. And when we hover on it, we can see that author of this this specific token is, in that case, it's me, is done in this date, and the commit message and hash is visible. We can see that, for example, this and every token could have different author. So this what we can do with ContextBuddy. Okay, second part of this presentation is the visual code representation. And here it goes a GraphBuddy, another VirtusLab extension developed internally. It is extension for the VS Code and IntelliJ and WebStorm as well. What it does. First of all, GraphBuddy will help new joiners for learning code structure and help to understand dependencies between your project. It could also help in refactoring, dead code elimination, automatic module extraction, or just give an architecture advices. GraphBuddy and use cases. You can ask yourself how the code is interconnected between different units. Should I extract some part to separate module? So we have example here. I know the quality of this image is not very well, but hope you will see what you need to see. There are a few fragments. Of course, you see that this is some kind of the spaghetti code, but you see, for example, that this fragment on the right side is some kind of the maybe microservice here. And another maybe is here. Also, there is here another part. So it could help us, first of all, it shows connections between them, between some modules, but also it could tell us that we can, for example, extract some part to another module. What is the exact path between one place in the code and the other? So we can just choose two tokens, and the GraphBuddy will find the path between them. It will show connections, show how it's going, and finally we can read it. Next one, is there already a semantically similar code? Previously I talked about copy-paste detection, but it check only the exact match. It doesn't check semantic of the code. But GraphBuddy can check the semantically the same code. So in that case, we have three functions, which are just the wrapper for the console methods, console log, warn, and error with proper names. And the copy-paste detection won't detect that this is similar code, but GraphBuddy can, because this is exactly the same functionality. Log, warn only with different names, log, warn, error, with the same parameters. With parameters has the same type, and it has dependency for the console, but only one difference is just the method of the console. So it can help you to, this is a very simple example, but if there will be some few places with bigger logic, it can help you to find two places and advise you that maybe you can create a generic function for both of these cases. Okay, another use case where this variable is used. Maybe some other packages use it. So we can also choose some variable and search for the connections, and it will show you where is it used. So this is something that GraphBuddy can do. Is that code a dead code? And what about monorepo? Because slint could prompt you when there is unused variable, but when you export it, it won't detect any problem. But GraphBuddy can detect that this this function is not used in whole repository. Okay, but what about the monorepo or two different repository which we has in our, for example, company? GraphBuddy can also merge two different repositories and detect connections between them. And when we talk about the TypeScript and, for example, monorepo like Yarn second or Lerna, it will detect that, for example, export three functions which is exported from module A, and from module B we just import one of them. So we can detect that here log is used because there are connections, but error and warn is not used. Okay. GraphBuddy, of course, can show structure of some variables or some types. Like here, there is a users, and we know this is the icon of type, and this is object literals, and available fields on the object. Okay, so I will try to go with a live demo. So first of all, it's available on the marketplace. So you can install it from the VS Code and as well the IntelliJ or web store. And after you open the window with GraphBuddy, you can, for example, show full graph, which will show you the structure of the project. This is the example of the TypeScript project pushed on our GitHub account. And yes, this is something which we can play with it. We can, of course, switch to 3D, so it will be some fancy look and feel, and we can go through with our code like it will be with our place. But to be honest, for the most of the analysis, we will use 2D. So, for example, we can. What's the main benefit? We can navigate when you look on the code here, and when we click on the, for example, email factory, on the left side there will be opened window with this token, and it will be highlighted. For example, we go to email factory and it's still there. As well, we can, for example, go from the init function. We can, by double clicking, add every connections of it. It will showing us what we can, where are connections, where are going. Yes. And for example, we can also find from, okay, and there is some email factory when we reset it, and when we also would like to see the init function, and then, for example, the some email factory. So there is an init and the email factory. We can also find the path between them. It will show you how it's going. From init to get user and send email to users, send single email, EF. Probably nobody know what it is. It was my intent, so we can check. But just click, and we will see that EF is just the instance of email factory. Yes. Okay. So this was just a short demo. Coming back to presentation. GraphBuddy is available on the marketplace, so you can download it. I recommend to download to play with it. If you will have some questions, do not hesitate to contact me. I will be very grateful for every opinion. Keep in mind that, of course, it is still in the first phase of development. Maybe not first, because we work on it a few months, but it's still under development. And some more information, you can find me on Twitter, so you can also ask me about GraphBuddy, as well for the every internally developed in the VirtusLab extension, but mainly I work with the GraphBuddy. Okay, so that's all from me. Thanks. And if you will have some questions, if we have time, I can answer now or later.
Okay, we have some questions. I've collected 3 of them. The first one is, the tools you presented show information about the state of your project here and now. What do you use to see the dynamic context, to know whether your app is today in better shape than it was yesterday? Have you tried SonarCube?
Sorry, would I try SonarCube, you ask me? Sorry, Peter, I didn't understood question. The last.
Can you hear me?
Yes, I hear you. Did you ask me, will I use SonarCube?
Yeah, have you used SonarCube?
Okay. I used when I was creating this presentation. It's quite nice. However, it's mainly used the similar static analyzing like slint, which is not very well configurable, as I remember. The main benefit of SonarCube is that it is not only for the front-end languages. So that's it. Will I use it? It's hard to say. Maybe I will consider to use it. I don't have a new project right now, so that's why it's hard question to me. But I will consider it.
Okay. The other part of the question is, what do you use to see the dynamic context, to compare day by day?
Sorry, what I will use as a dynamic analyzing for dynamic analysis?
I think the Macrusher meant that do you compare results of your analysis over time?
Okay.
To know whether your app is in better shape today than it was yesterday.
Okay. Of course, that's a good point. In my opinion, we should take this information. SonarQube, for example, does it, as I remember. It has a dashboard and show it. And in many of the continuous integration implementations, we have coverages. So we can always compare some coverages, some reports from the even static analysis, and we can compare it. And for sure, it's worth to do it.
Okay.
Yes, it's
okay, let's move to the next question. How GraphBuddy compares to the dependency cruiser? We find it extremely helpful together with TS unused export and SonarQube for different metrics like coverage and tech depth. This is asked by Michał, if I remember correctly. Yeah.
Sorry, I'm not sure if I understood correctly. You're asking me how GraphBuddy could help to SonarQube?
The first part of the question is how does it compare to dependency cruiser? Do you know dependency cruiser? It displays SVG graphs of your dependencies.
Yes. However, as I know, it showed just the dependency of the external modules. Am I right?
I think it lays out your code and the dependency graph of your internals also.
Okay.
Yeah, okay. So, I mean, I think GraphBuddy is more interactive from what I've seen right now. Okay, so we have...
It's in GraphBuddy, the main differences with tools which I searched is that, as you said, it's interactive. You can, we wanted this tool to be as close as possible to developer. So not no as some link on the browser or some different application, but just in the VS Code or IntelliJ. And we'd like to create something which is not only fancy look and feel, but something usable. And you can always, for example, you can track history of this, what you've been doing in your code with going to declaration, clicking with going from the function call to function declaration, and then you can render the graph of your flow. So there are many use cases for GraphBuddy which we can visualize what you've been doing, what you've been searching. For example, when we have some error and we would like to debug, we almost always we are going deeper and deeper from one function to another and to another, etc. And after 3-5 times when we go deeper, we lose our context. Where we start, I don't remember from which point I've started. So in GraphBuddy, we can, for example, render it, and you will see the whole every single function which you go through.
Okay, all right.
So
the third one is, how does GraphBuddy handle big projects? Thousands of files.
Okay, so if there will be a lot of nodes, when we talk about the performance, I recommend the 3D because it's done internally by WebGL.
Mhm.
In 2D, but for static analysis, probably we will never would like to show something which I show at the beginning. I mean, showing full graph, because this is a very small project. This is extremely small project, and it's completely unreadable. When we took much bigger, it's similar to some space with completely unreadable informations. So in huge project, how it could help? It could help when we choose another level of granulations. For example, we can limit to not show, for example, class and methods, or exactly show just the class and not show anything more. There are options for filtering these things. And then we can, for example, show dependency with granulation in module scope, or in module, or in the just classes, or just the functions, or imports and exports. So this is something which we can do in GraphBuddy.
Yeah, okay, I get it. So you can limit the granulation and
Yes.
hide the stuff that you don't need to focus on. Awesome. Okay, I think that's all questions for you. Thank you for your talk. I really liked it.
Okay, thank you as well very much.
Nice. I will surely install GraphBuddy after the meetup. Okay.
Cool.
Our second speaker, Mateusz Ziarko, is an engineering manager at VirtusLabs. He's a full-stack developer from origin and passion, and a founder of Wrocław TypeScript user group. To help us make our huge monoliths fresh again, Mateusz is going to cover microservices, Lambdas, and the controversial topic of micro frontends in his talk, Pimp Your Codebase and Scale It.
Yeah. Hello, everyone. Nice to be here, invited by Piotr. In that quiet, let's say, uncommon conditions that we are not meeting face-to-face, but online. Anyway, I hope you are going to be a bit enjoyed of my talk. So as Piotr introduced, I'm the engineering manager in our company VirtusLab, but don't treat me as a typical manager that doesn't know what is happening below, because that's the, let's say, next part of my career. So from origin, I was the front-end developer. Before this, also UX designer. So let's call it a small one-man army. Now managing a lot of projects and the teams and doing stuff after hours just to be up to date with everything. So let's jump in. So pimp your code and scale it. And hope you see my screen and we might kick off. So let's talk a bit about evolution of applications. We are not going to focus if there are front ends and back ends, how the evolution looks like in one or another, but we are going to focus on the overall. So a long time ago, when dinosaurs like me was on the world, there were monoliths. They are still there. I assume just a couple of us, of you, are still facing the issues with monolithic applications that you've got in your companies or your client got, that they would like to rewrite it, they would like to step to the next level. But sometimes it's not possible as easy as they would like to. What else? There are typical splitting between front-end and back-end. So we've got the front-end application. It might be, of course, the nowadays application written in React, Angular, Vue, or whatever. And we've got also the backend application, the backend API, sorry, which is written as a single app, but we've got the two blocks in that architecture. So typical connection back and forth. Another one in big projects are the microservices on the backend side, exposed by some API gateway as a API. So we are not seeing any difference to the second one, the backend stuff, than here from front-end perspective, of course. We are keeping the same stuff on our client end. But there is still a free gap here. So the micro frontend. So we've got, let's call it similar architecture, both on client and backend side. That's what's going to be the goal of my today presentation. But let's start from setting the state of nowadays. As I said, I'm assuming you are facing also with monoliths, but it might be a bit limited. Most of you probably got back-end front-end apps, or in that bigger projects and more up-to-date front-end and the microservices architecture on the back-end side. So let's say that we are going to focus on those two. We would like to rewrite our legacy app to the new architecture. What are the possibilities or even opportunities? Of course, we can start writing the new app and do the big bang. That's not going to work, as always. Each big bang got issues. What's the best option here? Legacy as a service. What I mean by this, we might call it like slow decommission of our current legacy application. That is, let's say, API layer, and rewriting it on the another version. So typical versioning. New version might be up to date with current languages, with a new environment, even architecture. So as I said, we are going to focus now a bit more on the backend stuff. As that's purely TypeScript meetup, I'm not going to talk about Java, .NET, or whatever. I'm going to focus on Node. We've got a lot of frameworks, libraries that give us possibility to write REST application, APIs, GraphQLs, etc., etc. I'm not going to say which are better, because that's our own decision, which framework we would like to choose, which we think that is going to be easier to maintain, or even which is more lightweight. Depends on our goals. Personally, I was using Nest.js, as it's also written, let's call it, by the Polish guy. So let's be a bit patriotic here. And what's the strategy? A slow choking and migration. So what I mentioned previously, we've got our legacy API with a legacy backend. Frontend stays the same. We are just changing the version name for the newly migrated endpoints. That keeps the same naming convention, just a version name is changing. Yeah. And we can also introduce new features to the newly written backend, because adding new features to the backend that we call as a legacy is not the proper way. Of course, our manager, for example me, might try to argue that that's the only one way, because it's can reduce costs, etc., etc. But it's like blindness. Yeah, it's going to fail in the long term. The other opportunity is the microservices. So what are the microservices? Solutions based on the microservice architecture are for sure decentralized. As we've seen on the previous pictures, we don't have a single instance. We've got a number of smaller instances that are independent from each other. So also development, deployments are fully independent, and that kind of architecture is much more automated than typical backend API. Also, each of microservice might be implemented in totally different programming language. So we might keep one microservice in JS, another one in Java, another one in .NET, so on and so on. Also, each of them might use separated database. Just like separated hardware, one of them might be really overloaded, so hardware is going to be from the top shelf. Another one is going to be less used, so let's say it don't need to be fully capability hardware. Yeah. Okay, now that should be a bit better. So just like here, we've got our front-end application. We've got also same legacy API with a backend under the hood, and we've got also new version of this API. API is exposed by API gateway like APG or something similar. It's also up to the solution. That kind of API gateway is going to expose each microservice under specified endpoint name. So for the user that doesn't know about the architecture, it's going to be nothing different in the usage. So we can build one after another microservice and decommission our legacy API. Is going to be much more easier than previous example with a slowly choking and decommissioning. As I said, I'm the most familiar with Nest.js because I was using it previously as a full stack developer. I'm still using it after hours in the company side project that I'm working on. So I'm going to base on the microservices example in the Nest.js. This framework is really well prepared for creating microservice architecture with number of different transport layers, etc., etc. So bootstrapping that stuff is from zero to hero is taking up to a couple of hours. If we would like to migrate our application to microservices by one shot, it's not the right way. We have to do it step by step and rewrite one microservice after another because it's not going to work. The next opportunity and the possibility is the serverless. I assume all of us heard about this, like Lambdas, like functions, Google Cloud, Azure, so on, AWS. Everyone heard about it. By the first look, serverless is quite similar to microservices because we've got a number of serverless functions, number of instances, so the concept is quite similar. But microservice It's a service in the full meaning. Lambda or the function have to be implemented for specific business case that is not run every time. So it's from time to time actions, because a lot of lambdas and functions are implemented by some kind of a warm-up mode and counted by each execution. So it's a bit different to typical AWS EC2, etc., etc. I might base on some example from my own work. We have built for the client the booking portal for the office spaces. So there was a startup that started to renting spaces, and they asked us to build that kind of a application. We build them typical easy booking form, management, etc. After that, they would like to get the mobile app. No problem, React Native, done. But no one might expect this. While managing, the photos starts to getting bigger and bigger and bigger, 4K photos of the brand new A++ offices. Fine. On the web app, works quite well. But on the mobile, especially on the 3G, it sucks. So what to do? Batch resize of the images? I don't think so that it's going to be a good thing, because we need to rewrite the application, write the specific scripts. So Lambda, you write in that case, the Azure function that resizes images on the fly because our React Native app was caching the images. So every time image was resized, it was just a single shot per device. So less traffic, warm-up mode, triggered couple times of a day based on statistics. That's some kind of a business case that might be realized by the functions. Except the example, lambdas and functions are very heavily platform dependent, because each of the platforms, Azure, AWS, so on, got different function definitions and hooks. So we cannot write it once and use everywhere. Of course, there are some tries to do this, but platforms don't have shared manifest, or there is nothing common between them. We might try to export our stuff as a separated library, etc., and write just executors for each platform. That might be the case, but each of them are going to evolve separated by its own way. So we have to maintain number of. And that's how it might lose the architecture of the serverless stuff that we would like to provide to our rewritten application. So we still got the legacy API with that big backend layer. And we are providing one after another Lambda functions. So it's quite similar to the microservices that we are calling from our front end by just changing exact URLs. How it's written? Those two examples are from different platforms, as you might recognize, because one is TypeScript, another one is purely JavaScript. So that's to expose the differences. as we see, naming convention, also let's call it API, is different per each. This one was used on Zeit, CO. This one is from Azure. And also each platform got own bindings. One got it fully automated, another one requires binding files. What are the bindings? They are ins and outs from our application. So I was talking about the Azure, I was talking about AWS, mentioned Zeit, that is currently the Vercel. The change was done 8 days ago. Also, there is a Google Cloud. For testing purposes, for learning, I've used Vercel because those three big players in the serverless area, of course, got their own prizes. Zeit or the Vercel is free of charge for easy learning usage or low traffic users. Got a lot of integrations and automations. So, for example, we don't need to take care about the bindings on current Vercel. Some time ago, when I was preparing content for this presentation and Zeit was still the name of the solution, there was a bindings. Now they automated it. So it's still evolving. And finally, something for client side, the micro frontends. So just to start talking about, we have to start thinking about our client apps not like packages. We have to think about composition of the functionalities, because we are going to build some kind of a wrapper that is going to expose one after another functionality, probably, and this is really recommended, build it and maintained by fully independent teams. Why? Because imagine that you are building the huge e-commerce. So it's impossible to get all business domains knowledge in one place. There have to be separated teams responsible for different areas. So that's the real use case for micro frontends. Each team have to also operate end-to-end and be multifunctional. So they are going to be responsible for their functionality from the beginning to the end. Also, if they are going to build some piece of a backend stuff, it has to be under one team. So the term of a full ownership of the features, not the app, the features. Micro frontends got 4 main concepts. Mentioned already the full ownership. They should be tech agnostic. So totally independent, just like microservices. That's quite similar architecture. Because we've got services there, here we've got features and components. They have to also use the native browser API instead of some custom APIs written to communicate between the components. Because we are going to have the wrapper that have to render the components. Somehow they have to communicate. So we've got it 2 ways. We might create our own pub sub API But why? We've got browser events. So our components are client-based. So let's use browser events. So less custom, more native. Also, micro frontends have to be always available and always accessible. Of course, if our wrapper is going to fail, we are not going to say anything. But as micro frontends are totally independent, they have to be prepared to show something on the init. So to be a bit isomorphic, but I'm going to explain it a bit later. And as I also said about rendering, we have to use server-side rendering and universal rendering in that case. And that's the meaning of isomorphic web apps. So the combination of server features and client features. So we might have the front-end app rendered on our server that is also single page app. And mentioned example of e-commerce. So in the basis, we've got our e-commerce wrapper, and we might divide it into 4 different components: account component, basket component, let's call it promo Jumbotron. I really love that name, Jumbotron. I don't know from where it comes, but marketing teams are using it. And also typical content. So it might be easily splitted into identity team, checkout team that is responsible for the basket, identity is responsible for account, marketing team that I already mentioned for that big promo Jumbotron, and also content team for our tips, so on and so on, providing, etc. So easy division of responsibilities that give us also fully tech agnostic. We might write each component, implement each component using totally different stack, like React and TypeScript, Vue.js and ES6, so on and so on. We don't have to use the same technology stack. So the teams might be located in different rooms, even buildings or continents. We don't care, because we've got our own piece of work that we are responsible of, that we are managing, implementing, maintaining, deploying, and monitoring. I'm talking about micro frontends, but I didn't mention any other frameworks yet. So in the basis, I've took, I think, the 2 most popular, so the Hypernova and single SPA. Hypernova is, as we see, the Airbnb framework. Single SPI, not a big player, but I've updated the stats today. Previously, Hypernova was much more popular than single SPI. Today, roles are different. So the world is changing still. Anyway, as a lot of us using the Airbnb stuff, I also, as an example, I've used the Hypernova, as is quite similar anyway in the concept, but different, written a bit differently. So in the basis, we are creating our core renderer of a Hypernova that renders our components that are held in separated files, and we are exposing it on a specified port. that bootstraps for us the whole stuff of server-side rendering of our micro frontend wrapper. And here we've got our React micro frontend component. Easy hello world stuff. It might be also much more complex. So the only, let's call it, different stuff from typical component is that we are using the render React from Hypernova, and we are exporting our rendered component to be able to render it on the server side. But after that, it might use the SPA functionalities. So what are the biggest pros that gave us micro frontends? For sure, easier and the long-term maintenance, because we've got independency. We might go using our own backlog. We don't need to deploy whole applications, so also deployments are easier. So if, let's say, the marketing team is going to fail with a deployment, it doesn't mean that our application is not going to be accessible. It will be, but there will be just a problem with a Jumbotron. So some kind of a placeholder have to be displayed, as we are focusing on the speed of of isomorphic web apps. So just to use an example, what we mean as an isomorphic web app that I was talking about previously also. So now I'm going to give an example. Imagine that we are creating the block. So how we can isomorph this? First of all, our return us list of posts, because that's a big query to the database, statistic, etc., etc. So it's going to be just a first render. But after that, if we are clicking onto exact post, it's going to be purely client behavior. We are not going to change URL and render everything else. We are going to use client-side routing. So it's going to be the React app. Content is going to be fetched and present, because it's going to be just a single code and client-side rendering. So we are not losing time for re-render everything. That's the basic example of a isomorphic web app. And we've got a goal achieved of a micro frontend. So, but that kind of a decision to go with our current application to be the micro frontend, what we should do? First of all, we have to set a wrapper that might be one-to-one to our current application if we are rendering it. And step by step, we might exchange rendered parts from that wrapper into our separated micro frontend components, and let our app to be more divided and independent. That's all from my end. Thanks for attendance. If you are interested in, you can catch me on a Twitter or find me on LinkedIn. So happy to talk with you.
Nice. Thank you for your talk. That was pretty cool. Okay, I think I'm the only person who had questions. So I'll use this possibility to ask all of them.
Okay, let me turn the light on.
Yeah, sure. Okay, you've mentioned isomorphic apps, right?
Yeah.
And how do we server-side render an app which uses Vue, React, and Angular? Like, is it possible? Because you mentioned that the shop website is built by content team, the identity team, and the checkout team.
Yep.
So if they choose different frameworks, we can't really optimize that application, right?
We can, because what we are doing, we are creating the wrapper. Yeah. So we are creating that kind of a isomorphic app. So that is going to be the server side of a stuff that is going to render what we should see on the beginning. Yeah. And each component is independent and might behave fully independent, include own stuff. Of course, the example used there, especially with Angular, was not a good one, because importing Angular a couple of times or combining it with React is not going to be enough efficient. But with a tree shaking, it shouldn't be the real case. That example was just to show you that it is possible, but let's say it's not recommended stuff. The main pro of micro frontends is that you don't need to follow exact stack, so you don't need to use even the same versions or full stack of other team that got a lot more libraries to import. Yeah, you might set up your own component using the same version of a React, but with different dependencies.
Okay.
And you can render each component independently, deploy it, etc., etc.
Okay, so my understanding that this approach is really good for huge teams, for big companies, right? When your product is built by...
Especially for the big teams. Yeah. I gave an example of e-commerce because, as we talked in the past, you know that I'm working especially for the project for big grocery. Yeah. So there is a big e-commerce also there, and that's the approach used in that kind of a project, because to keep that kind of e-commerce up to date, especially for the different regions, requires number of people, requires being up to date every time. So splitting onto micro frontends and giving responsibility to one another team is the right choice. Of course, you can adapt it in a smaller team, but as a team, you might set one or another developer, let's say. If you might ask if it's going to be efficient enough, I can't say that. If it's going to be or not, is the choice and the decision of each team, and some kind of a prediction how big might be the project in 1-2 years.
Okay. How do the monoliths and microservices / micro frontends compare from my perspective of a manager?
From the perspective of a manager?
Yeah. So I'm asking about like developer productivity, time to ship features.
Also, of course, it depends from the person. Yeah, I might base on my own example. When I joined current project, I've got monolith, but I was asked to add a couple of features there. I don't want to get back to this. I would like to forget about that time, how it happens. So we decided to divide it and divide and divide. Yeah?
Okay.
Because
I get it.
you know, keeping monoliths is always a choice between being up to date, easier maintenance, especially the maintenance, because you don't know what monsters and nightmares are under the hood. Because monoliths are always inherited, or almost always inherited from previous teams. That was in our case. We have inherited the monolith from the team without know-how. So that was like walking in a fog. Am I going to crush something or not? How it's going to behave? Yeah.
Yeah.
A lot of approaches in one big piece of work. So we cannot say that it was some kind of a comfort zone. And migrating it to micro frontends and microservices was the only right choice. Of course, it wasn't easy, but from the time perspective, I see a lot of pros now, because now we might change just a one microservice, redeploy it, we might change one part of a frontend, redeploy it. We don't need to deploy the full apps.
Mm-hmm. So I come to think that micro frontends are a solution to a organizational problems even more than they are to code architecture problems, right?
Also,
same thing with microservices.
Also,
Yeah,
as you see, I'm talking about this from the perspective of a manager, not only the developer.
You had this big chunk of unknown behavior, of complexity, and just to tackle it, to make it maintainable, you decided to split it up.
Yep.
Okay. Krzysztof asked a question. What about problems with distributed systems? What are the cons of having micro frontends?
As always in distributed microsystems, differences and versioning. Yeah. So yeah.
I think we had then a lag and it was stuttering. So could you repeat that sentence?
Of course. Of course, yes. What are the cons of using micro frontends like a distributed system? That was the question. So, as always, we have to remember that independency is also the responsibility. Yeah, we have to keep everything up to date. We have to version everything properly, because without this, with a monolith apps, we might just do the changes without back compatibility, because we are redeploying. That's all. With the micro frontends, and especially with the microservices, we have to keep in mind that amount of users, of the clients, are going to use our previous version. So we have to be still back compatible, at least 1-2 versions in the past. We cannot do the changes live without providing proper backlog for our versions. So that's also the stuff for the manager, product owner, or any other person, the tech lead, to manage it and keep transparency and consistency. So that's the main cons of using micro frontends here. It has to be well organized. It cannot be like a rush, that we are doing something, and so on. We have to always keep in mind that we've got users that are not up to date. And we've got dependencies that are not up to date because we are not updating all dependencies every time. I hope I answered the question.
Yeah, that's a great answer. Okay. Awesome. Thank you for your talk and for your answers.
Thanks.
And thank you all for attention and for being there with us despite our technical problems.
Thank you.
See you next month.